In this video, I'm going to show you how I mechanically hacked my keyboard with a Dremel from this PCB to this keyboard. So first off, let's start with the why. I first got into the world of small-sized keyboards a while ago when I stumbled upon Plank. At first I thought these people were a bunch of memers, but then I saw a video or two and found this kind of keyboard pretty interesting. I didn't want to make a huge investment and decided to chip out on the parts and went for the poor man's version of the Plank, which is Contra. I put together the monstrosity that is this keyboard right here. It literally doesn't even have a case, just a few 3D printed brackets, if you're willing to call them that. Anyways, it was functional and I really enjoyed using it for my job. But eventually I fell victim to the hipster-hating developer who, in hindsight, was probably scared that this tiny keyboard could be anything near as efficient as their $900 Razer gaming keyboard with a bunch of LEDs. So for a while I was really buying the custom equals bad meme. What if someone tries to type on your PC? What if you can't bring a keyboard with you? I went as far as to kill my beloved Contra and build this basic poker keyboard with its parts. But eventually my love for tiny keyboards prevailed and I bought the parts and assembled this sweet low profile Korn, which is really a pleasure to type on and it's probably a keyboard I still like the most. I can't say anything bad about the Korn really, but I got tired of packing it into my bag whenever I took a laptop with me. Fortunately, I remembered I have some parts of my old Contra still hanging around in my basement. I quickly found out that I basically have all the parts needed to assemble a full Contra. Although I was a bit hesitant due to the slight difference in layout between the two mentioned keyboards. If you count the keys, you can see that Korn has 6 keys less than Contra. Then it hit me that I can maybe just leave these keys out and not solder these 6 switches. But we can do even better. If we clone Contra's repo and open the PCB file in KiCad, we can inspect the traces, and if we do the cut like this, we only cut one trace, which we need to gap later. There are a few spots where we need to be extra careful, but otherwise that should be it. Now, we could do that on the PCB itself, since I already have it manufactured, but it's easier in KiCad because you can see both sides of the PCB at the same time. Next step. Put the tape on the PCB so that we know where to do the cut. Then we turn on the Dremel and bam! Look at this beauty. Seriously, it went a lot smoother than I ever imagined. After I removed the tape and cleaned the dust, it doesn't look all that bad. So before doing the soldering, I decided to turn the keyboard to hot swap. There are dedicated sockets which you can buy and are made specifically for this use case, but they're a bit pricey. So I went with the cheap route again and bought a bag of these rivets for a fraction of their price. My idea was to solder these in place and then when inserting switches I'd bend the pins just a bit so they'd make good contact. Now before we continue, this is something which I gambled on a bit, but at the end it turned out quite nice. I've been using this keyboard with these rivets for a few months now and I haven't come across any big issues. Some switch pins do lose contact from time to time, so they need adjusting, but otherwise it works just fine. One thing which I realized with my previous keyboard is that if you use hot swap, you also need a plate to hold the switches in place. So that's one thing to keep in mind. Alright, back to soldering. I put a strip of tape on the back of the PCB, inserted these rivets in place, turned the PCB over and removed the tape. This ensured that the rivets were flush with the PCB. Then I soldered these rivets to the PCB and repeated the process until everything was fixed in place. Next step were the diodes. Nothing special here. First I bent the pins, inserted the diodes into place and soldered them. Obviously I needed to cut off the excess wires which were sticking out of the PCB. With the hard part out of the way, all there was left to solder was the Pro Micro. I used this purple USB Type-C one from AliExpress. One slight modification I needed to do was to tear one pin off the header. This was to address the cut PCB trace which I mentioned earlier. To bridge the connection, I used a jumper wire that is usually used for when working with breadboards. It was easy to bend in shape and solder both ends. At this point it also makes sense to test the functionality of the PCB by flashing the firmware on it and testing if individual keys work as expected. Next step is the case. I designed it in FreeCAD since it's pretty basic shape and I assumed it would be up for the job. I exported the modified PCB from the KiCad and got a Pro Micro 3D model online and shaped the case around it. It turned out pretty well in my opinion. After I was satisfied, I exported as STL and printed it with my trusty printer. Screw holes on the case are designed in a way to use these metal inserts. The way it works is that the holes are a bit bigger to account the extra width of the insert, and then you heat them up with the soldering iron and push them in slowly. A trick is to not heat up the iron too much. About 170 degrees is plenty, otherwise you might end up with a mess. At this point, all there was left to do is to assemble all the parts together. PCB into the case, added these tiny standoffs, and finally a plate. I use these cream switches from AliExpress. I don't really care that much about the switches, I prefer linear and that's about it. Silent ones would be nicer, but hey, they're cheap. If you want to have a proper review about the switches, I'm not the right guy to do that. All I know is that they feel nice. Here you can see the slide band in the pins I mentioned earlier. It's a bit tedious to get the right band, too much and you miss the pin socket on insert, or too little and it won't make proper contact. But by the time you get to the last switch, you get used to it. When the switches are in place, all there's left to do is add keycaps. I hate these green keys, but that's what I have and that's what I used. So here's the finished keyboard in all of its glory. Anyways, now for the firmware. Obviously, I already had to pick a firmware when I tested it with the bare PCB. But hey, I already have a script written, so I won't go back and change that. I went with the QMK firmware, which is what Contra uses. Now, I could make a new layout and all that, but who cares? As long as it's functional, it's fine. Basically, what I did is copied my Coron layout and left out these 6 keys. I also made this shitty script which does this for me automatically. So adjust the Coron layout, download, script, and we have a Contra layout. I'll also put a link to the repository with this script and other keyboard related files I use in the description. Now compile and flash, and that's it. So here it is. I hope you learned something new today, even if it's just a basic PCB hack. Now, would I recommend this kind of thing to anyone? Of course not. But what I hope you take from this video is that you can do quite a lot with the things you already have. If you have a PCB which closely resembles what you want, you don't necessarily need to go out and order a new one. You might just get away with something like I showed. Alright, if I learned anything from Keeb videos is that you can't finish a video without a proper type test. So here's one for you, and thanks for watching.